All right. So the first thing that we have to understand is actually now we know how to find out the composite function f of g of x, or we know how to find out the composite function g of f of x. But the problem is that what's their relevance? Like, are they valid statements, or when they're like, how can you find out the domain and range of the composite function? When will they be actually defined? Now, let me give you an example. For example, f of x is, let's say, x plus 1 for x values between -2 to 3. And g of x is, let's say, x squared for x between 0 to 5. Now, what I would like to do is, I would like to find out, let's say, f of g of, let's say, 4. Now, I'll first find out g of 4. So g of 4 is going to be nothing but 16. Now I'll find out f of 16. Now f of 16 ideally is 17. But the problem is that I cannot find out f of 16 because you can see that x is only defined between -2 and 3. So I can't find out f of 16. This is going to be irrelevant because I know for that matter of fact that, okay, f of x, if it has got natural domain, x plus 1 is like a line like this. When I take x as -2, it's here. So if I take -2, if I plug -2 here, so the y value is -1. If I take x as 3, it's y as 4. So here, so we can see clearly that your range that you have, domain and range for this particular question, is not allowing us to find out f of 16. So there is something wrong that within our understanding, we have not been able to kind of clarify that. So now there is a rule that you need to understand in order to f of g of x to exist. Remember that this is g of x is the range of y value for g. And f of, now this is acting like a x value when you input here in place of f. So when you're finding f of g of x, remember that range of g must be in domain of f. So range of g should be subset of domain of f. So if it is in domain of f, then like, see here, you could see that range of g that I found out, it is not in domain of f. And that's where it was undefined. But just imagine that I extend this, I just find, I make this domain from, let's say, until 30. Now you can find out. So the only difference in both the scenario that is happening is that your range of g, if it's in subset of domain of f, then only f of g will be defined. F of g of x is defined. And if it is not, obviously it is not defined, but doesn't mean that it won't be defined for all x values. In that case, we have a little bit of clinical way to understand that. Similarly, when you're doing g of f of x, it will be defined only if range of inside, which is range of f, is subset of domain of g. So range of this must be in domain of g. So like domain of g is like the bigger pond, and f of g of x ranges are like smaller ponds. So smaller pond must be in bigger pond in order to exist. I mean, f of g or g of x, g of f. So this is a very important key concept to understand, like when is f of g of x undefined or g of f(x) is undefined. Let's take an example to make this thing very clear. So consider that f of x is a root of x and g of x is x squared minus 4. F of x is root x and g of x is x squared minus 4. And I wanted to check whether f of g of x is defined or not. Is defined. If it is not defined, if not, when it is defined. When it is defined, or how can we make it defined? So first thing is that let's just look at this. If I look at the f of x graph, the f of x graph is basically, this is the graph like here, root x graph. So if I make a matrix here, let's say this is a matrix, I would say. This is domain, range, f and g. So for f of x, you can see the domain is x greater than or equals to 0 and range is y greater than or equals to 0. For the second function, x square minus 4 is something like this. X square graph moved 4 units down. So domain is x belonging to real number and range is y greater than or equals to -4. So let's check out once again whether f of g of x is defined or not. So you can see that when I find out f of g of x, range of g, which is this, must be in domain of f. Domain of f. Now, if I look at a number line, a simple number line is that, okay, x greater than 0. When I look at the first one, is x greater than 0. So x greater than or equals to 0, that's this part, which is here. And the second one is basically y greater than or equals to -4. Y greater than or equals to -4 is here. So you can see that this number is not in domain of f. So this is your range of basically g, and this is domain of f, which is not entirely in domain of f. So hence, f of g for the given situation, at least f of g of x will be undefined, because you can see that if my output, like output of the first function, is not in the domain of the second, outside function, then it won't be defined. Now you can clearly see that it is not a case that it will be defined, it will not be defined for all the x values. There are certain values which, if you can cut down from the range of the inside one, if I cut down or remove this part, you can see that if I remove this part, and instead of taking the range as y greater than or equals to -4, if I make the new range, if I redefine this function, from y greater than or equals to, let's say, 0, okay, then you can see that this entire number is a subset of x greater than or equals to 0. All the numbers are out here. So it means that any number that I put out here now becomes basically the subset of domain of f. So this is something which is like, how can we make it defined? Okay, so now because you have truncated this, so this domain will not be valid anymore. So since now I'm going to take the function f of x is, let's say, x squared minus 4, g of x is x squared minus 4. So this is like -2, +2. So I basically removed this part of the function. This part of the function is removed now because I'm taking the new range as this green part, this part, y greater than 0. So this part is only existing, and clearly see that I'll have to modify the domain now. So x greater than or equals to 2 or x less than or equals to -2. So this is basically, you check and understand, this is how you actually critically think about whether f of g of x is relevant or not. Okay, and secondly, like, this question could have been solved very easily also. I'm just telling you the logic of it. Like, you could have just found out expression for f of g of x. F of g of x will be root of x squared minus 4. And then you could have applied a normal logic that in order to be defined, x squared minus 4 must be greater than 0. And that's what exactly we did. That instead of taking the natural domain, I made x squared minus 4 greater than 0. And that's where we have done here. And now if you solve for this is like simple inequality. Number line, you could put -2, +2. Here it will be positive, here it will be negative, here it will be positive, because happy phase graph. So I'm just gonna tell you, like, whichever way you are looking at, but make sure that you understand that when it is defined only if the range of inside is the subset of domain of outside. Secondly, a very interesting one is, like, for example, if I look at g of f of x here. So if you look at g of f of x here, so g of x, f of x, now range of f, if you look at is y greater than 0, is it in domain? Like, this is, I'm talking about the original one. So let's talk about the original part of the function. F of x is, let's say, root x, and g of x is x squared minus 4. Now, I wanted to check whether is g of fx is defined. Does g of fx come in picture? So g of fx is defined. Now, let's check out the metrics here once again. So this is your domain, range, fg. So domain, range, f, and g. So domain here is x greater than or equals to 0, range is y greater than or equals to 0. Here it is x belongs to real numbers, and range is y greater than or equals to -4. I want to check, let's say, if my g of fx exists. If it exists, why? So first you look at here that the range of f now, range of f is greater than 0. So range of f is here, and domain of g is x belongs to real number. So now domain of g is your range of f is in this, which clearly says yes, because all the numbers that are y greater than 0 also they're real numbers. So hence g of f will be defined. Now, in turn, if it is defined, then what happens is that there are certain conjectures you can draw. So basically, you're inputting this x value firstly in f, and then only you're getting this range. So the domain of g of f, if it is defined, is same as, so domain of g of f, if it is defined, it is same as domain of f. Remember that this is a rule. If it is completely defined, then it is same as the domain of f. So common sense is I'm going to plug this x value, because this I can't take any random x value here. This first I'll plug x as 0, then only I'll get the answers as y as 0, and then I'll input that out here to get g of fx. So this is very interesting puzzle, and this is where we need to understand the domain and range very critically for the f of g of x. As far as range of g of fx is concerned, you need to use your brain. You can't directly get that, but at least domain you can get it easily. So if let's say f of g of x is completely defined, then range of domain of f of g will be same as domain of inside, because it all starts with this x. So this is how you kind of tackle the domain and range issues of the composite function.